Here's Denny, our host today, and we got Paul Offord from TribeLab, one of our keynote writers.
Thank
Denny,
you, Tim.
take it away.
Thank you, Tim. Thank you. Good morning, good afternoon, good evening, wherever you are. Welcome to another episode of LMTV. Today, our special guest is Paul Offord. Good evening, Paul.
Hi, Denny.
How are you?
Yeah, good, good. Suffering a bit. It's very hot here in the UK, 30 degrees plus. So I don't know what that is. That's 75, something like that. I don't know. It seems hot to me anyway.
So you're wearing a different hat today. You're actually wearing the hat of a project leader for TribeLab, not for Advanced 7.
That's right.
So my understanding is that you're giving an update, a hot piece of software, right?
Yeah, we some time ago we released a plugin called Transum for Wireshark, and it's been a while since I've been on the show and talked about Transum, so I thought I'd give an update, see where we are.
Okay, cool. Take it away.
Okay.
Hey, Paul, first, I have a question right up front, Paul.
Sure.
Go ahead, Tim.
How did your training go at Wireshark? You did your lab, your bench, what do you call it?
Workbench. Yeah, we presented Workbench, the Workbench software. Yeah, it went really well. We had a lot of interest. In fact, in the area we were in with our stand, we had more visitors to our stand than any of the others by some long margin, actually.
That was because you're giving away a cold beard. Come on, be honest.
Yeah, that was all the gifts. But we're actually, I'll talk about TribeLab at the end of this, but we're actually going through a really significant rewrite, and it's quite exciting. So I'll tell you a bit about that at the end of this presentation, because it sort of dovetails with this a bit. Great. So let me start. I need to share my screen. I need to put some glasses on as well.
Uh-oh, sweaty glasses.
Yeah. Okay. So, are you okay with my slides?
I probably do.
Yep. Good. Okay. So, yeah, thanks to Denny and Tim for inviting me on to talk about this. I'm going to talk about this Wireshark plugin called Transum. So, Transum in one of the languages supported by Wireshark, and it's a language called Lua. And there are good and bad points to that, which I'll cover later on, and I'll tell you a bit about the future and what we're going to do to overcome some of the downsides of using Lua as the language. What Transum does is it provides you with some quite detailed response. Now, standard Wireshark out of the box does provide some response time information, but there are some gaps in the information that it provides, and in some cases it can be misleading. Transum overcomes some of those issues and provides a bit more detail, which we'll see in a second. What Transum does is it breaks down the response time that's seen on the wire, on the network, into overall response time, network time, and then delays in the service you're talking to. So the service might be a database or a file server, whatever it is, it identifies each piece of the overall response time. So that's great because that enables network managers and network engineers to determine whether the slow performance of an application is a network issue or whether in fact it's a problem with a server or an application. So this is the type of information you get. Now this is a packet list from Wireshark, just a standard edition of Wireshark, but with the plugin installed. And we can see that we have some additional information up here. We get these response time figures, and we get these figures called spread, request spread and response spread. And I'll explain a bit about what those terms mean and how they're being measured, and that will give you an insight into what we're trying to achieve with Transum. You also note that we support quite a range of protocols. In fact, there's a couple missing from there. DCRPC is one that's missing from that list, and that's a protocol that's used when Outlook is talking to Exchange. So when you're sitting at your looking at emails in your mailbox, and Outlook is retrieving information from the mail server, more often than not, it's using DCE-RPC protocol. Now, this information has been added just in the normal way that you would add information into the columns, into the packet list in Wireshark, and that is you click on a value and you say add as a column. And the detail, within the detail of the packet, you will see this additional information where it says Transum RTE data, and then we have all these additional values. And this is giving us the information about the start of a request, the end of a request, the start of a response, the end of a response, and how long each of those things took. And then we've got this handy thing at the bottom, which is the ability for us to just quickly copy and paste from this area here a filter term which will just filter out this particular transaction that we're looking at. So I'll demonstrate some of this stuff when we get to actually look at some traces. So it's important that I explain some of this terminology. Now, we base the analysis of response times on a particular model that we call the RTE model, response time elements. And if we imagine something quite simple where the user is looking at a browser and they click on a button, and that click results in a request being sent to a web server. Now, between the time you click on the button and the time the first request leaves, there may be some processing time inside the browser, and we call this client time. And then we send the request. And if we were filling out a rather large form or something like that and we pressed a button, we might have to transfer more than one packet full of data to the web server. So the data gets spread across a number of packets, and we call this the request spread. And this is the time it takes to send all of the packets that make up the request. Then the web server receives the request, it processes the data, we get some service time, so the time it takes for the web server to actually form a page, and then it sends a page of data back, again, maybe split across multiple packets. The browser, and that takes a time, and we call that the response spread. And then the browser takes some time to actually process that time, that data, before it renders it onto the user's screen. So we can see that the overall response time here, this response time here, from the start of the request to the end of the response, we call that the APDU response time. So that's the total time it takes. And from the client perspective, from the browser, that's the delay, all of that value there. On the server side, sorry, yes, Tim.
Yeah, could you explain what APDU means so people understand the acronyms we use?
Yeah, so APDU is an application protocol data unit. So it really refers back to the old OSI 7-layer model. And you may remember that the top layer of the 7-layer model is the application layer. And this is the protocol data unit that's sent from that application layer. So we're looking at the top level application data here, and we refer to that as an APDU. So this is a good question, actually. So what that means is that all of these packets here, these 4 packets, they make up a single APDU request. And these 3 packets here make up a single APDU response. So that's where the term APDU comes from.
Thank you very much. That's great.
Okay, so so the important parts here, from a networking perspective, obviously, if we get a slow APDU time, then we know we've got a problem, and then we can use request spread and service time and response spread to determine where the problem actually lies within the end-to-end system. So let's just elaborate on that a bit further. Sorry, that shouldn't say workflow steps. That's got the wrong heading. But you'll have to excuse me on that one. So high APDU response time means that we've got either a network or a service issue. There's a problem with the network, or there's a problem with the web server or the file server or the database server. A high service time means that the problem is actually in that server. It's not on the network, because the service time, if you remember, is the time it takes for the server to actually process the request. And then if we have a high spread time, this is where it gets interesting from a network point of view. So a high spread time is caused by a congested network, excessive packet queuing, things like TCP flow control, maybe higher error rates causing excessive retransmissions, all of those network type of things that you see people like Hansang and Betty and people like that and Laura going into a great deal of detail. But the great thing here is that if we have already determined that we have a high APDU time, and then we determine that we've got high spread values, that's when we can then make best use of the approach that Hansang and Betty and Laura spend a great deal of their time describing, because then we can really dive in and find out what's causing that issue. So since I last presented on Transum, there are a couple of new features that are worth mentioning. The first one is support for DCE-RPC, which means that you can analyze email issues with Outlook and Exchange. Unfortunately, Outlook and Exchange and the protocols being used are going through a number of evolutionary steps. So DCE-RPC is not always used now, and in fact there are 3 different variants of protocol that are being used just for native Outlook to Exchange, which is can be quite confusing. But where DCE-RPC is being used, and that's probably still 70%, I would think, of enterprise setups are still using this protocol, then you can use Transum. When we were at SharkFest, we were approached by a guy from Sweden called Matthias, and he said, "I really love Transum, but I'm getting Oracle data via an ER-span session, and I'll talk about ER-span in a minute, and Transum doesn't interpret it." And he was quite right, it doesn't. So ER-span is a protocol that's used to encapsulate spanned traffic in an IP packet and then transport that across the network in what is effectively a GRE tunnel, and I'll show you that in a second.
That means he has unlimited bandwidth, doesn't it?
Yeah, I guess so. If he's if he's shipping a lot of spam traffic around in his IP network. Now, I tell you where
my first comment would be, obviously, if you do an ER span, you're not interested in real timing because you're not going to get it.
I know your thoughts on this, Tim.
Yeah, no, I mean, I'm being logical here. I mean, if you're doing ER span, you're not going to get real timing. You're going to get subjective at best.
You're gonna get a level of error. I agree, but you're gonna get it probably close enough for what he's doing. If he's looking for long-running database calls, then he's going to be able to identify those. The one area that ER-span is now playing out in quite a big way, I think, is spanning virtual ports on a virtual switch. Now, the trouble is that what you ideally do is you want to get the traffic that's going in and out of a virtual port on a vSwitch. You need to get that out into the outside world so that you can feed it into your InfiniStream or your Gigastore or whatever, or your NetShark. And ER-span is one way you can do that. So
yeah, but that's what you're talking about, a VACL, which is a VLAN copy.
Yeah.
So one of the problems you run into there, you don't know whether it's send or receive data. And that kind of confuses a lot of time when you're trying to do response time stuff. So, but I mean, it's a way to get traffic.
Yeah. Yeah. Okay. So so this is additional support that we've added into Transum, and it now supports ER-span. Okay, so let's have a look at trace example. Make sure I pick the right one. So here's DCERPC breakdown. And so here you can see, as we saw before, you see the APDU response times, the service time, the request spread, and the response spread. Does this appear magnified to you? Is my magnifying thing working? Tim, has this expanded so you can see it?
Yes, I'm sorry, my mic was off.
Okay.
But yes, it looks great. At the bottom, you may turn off that Google share or
oh yeah, okay.
because sometimes that gets in the way of things.
Yeah, that is a bit obtrusive.
A minute ago, when you had a slide up, it covered up the TribeLab logo and everything.
Well,
at the bottom.
Can't have that. That definitely can't have that.
There you go.
Okay, so so we've got the DCERPC response time information up here, and again you can see down here in this area we have the detail actually embedded into the packet detail window of Wireshark. Now I mentioned this thing about the trace clip filter. So for example, what I can do is if I'll just take this first one. I can very quickly just filter out this first transaction by right-clicking, say, prepare a filter selected. I have to do a silly little thing where I delete a few bits like this because for some reason Wireshark won't let me put it in as a correct filter term. And then I hit enter and it immediately just pulls out that single transaction. So inside Advanced 7 at the moment, we've got an overarching project called Faster. We're trying to find faster ways of doing everything, and this definitely feeds into that whole idea of faster. So you can see that very quickly, rather than me having to work out what the filter term would be for me just to pick out this one transaction, all I had to do was right-click and say prepare it as a selected set of frames, and it immediately does it. So that's a big performance boost for us. So that's the DCERPC piece. I thought I'd show you the Oracle piece. So here's some Oracle data, TNS data that's being sent via a GRE tunnel over IP and Ethernet. And then you can see within the GRE tunnel we've got another Ethernet header, more IP, more TCP, etc. So that was the challenge that we had and that we overcame, and actually included that that support in there. Okay. So I talked a bit about Lua and about the downsides, and the advantage of Lua is it's quite quick, it's quite easy, and there's a lot of documentation to code Lua dissectors, I can certainly code them faster than I can code C dissectors in Wireshark. So there's a bit of a productivity bonus, but there is a performance downside. So here what we see is a comparison of loading a 47 meg trace file into Wireshark. If we haven't got any Lua dissectors installed at all, the file loads in less than a second. If we install Transum but we disable it, it still takes 2.5 seconds, and with it enabled it takes 5.4 seconds. And I think I saw a post from Betty saying yes, it is a performance penalty, but it's a price worth having if you can get the performance information, which is a good way to put it. And I'll talk in a second about how we can run Wireshark with and without the Transum Lua installed. And then we also did a comparison on filtering. So we did a very simple filter. Without the Lua, it took 1.7 seconds. With Transum, 2.9, and then with Transum enabled, 5.2. So there is.
Yeah, but you're getting a huge benefit from that, Paul. It's
you
not.
Are. Yeah.
Those numbers really don't represent, because you're running a program that's dissecting stuff and making it usable.
Yeah.
And much more visual, much more valuable. So that's kind of, to me, that's kind of like, well, you know, it takes me 4 minutes to run 10 feet if I'm happy, and I can run that same distance in 1 second when I'm scared. I'm still covering the same distance. Yeah, but I'm getting more benefit out of it. So.
Yeah. Okay. So in the documentation for Transum, you'll find that it talks about different ways of starting Transum, and the way that we recommend is to always start Transum with a specific command, and you can just add it into a batch file. It's a very simple command, but it just means that when you normally start Wireshark by default, it starts without Transum installed, and when you need Transum, you simply double-click on the batch file. It fires up Wireshark and gives you the Transum plugin. So that's how we recommend running it.
It's a very powerful addition to Wireshark. A lot of people just love it.
It's the most popular, by far the most popular of the software downloads on the TribeLab site, by probably twice as much as the next download.
I've probably heard from 15 or 20 people about it, and they just love it. They say, you know, it's intuitive to them. To me, I don't do enough troubleshooting like you do, but it's an awesome product. Everybody that I know that does professional analysis work has loaded it down and uses it on a regular basis.
Yeah,
very valuable. Great job.
It was good. It's funny because this Transum is actually, you could call this son of Transum, because we actually wrote the original Transum code in the mid-90s, but we wrote it with a programming language called SAS. So we were processing trace files with this language called SAS, and we had a Transum program that we used, and this is an adaptation or an adaptation of that original version. So it's been around a long time now. So let's talk about the future of Transum. First thing is we're rewriting it in C. We're probably about 30% of the way through it at the moment. I don't think it's a massive job, but we've got a ways to go to complete it and make sure it's solid. It was really prompted by a developer, Alexis, one of the Wireshark core developers, who kept sending me emails saying, why don't you rewrite this in Shark and submit it upstream? So we are going to submit it for incorporation into Wireshark base product. We haven't got a commitment that says it will be accepted, but there's certainly some interest, so hopefully that will be accepted. And that will be great, because then the community can go on and develop it much further than we can do with just 2 or 3 of us working on it. And we're going to integrate the capability into Workbench. I said I'd talk a bit about Workbench. One of the things about Workbench, the original version that we produced was very much a proof of concept. And as you mentioned, Tim, we took it to SharkFest and we got some good feedback. The funny thing is, it wasn't anything like the original design spec that I produced. I produced a load of slides that said this is what it should do and this is how it should work. But for one reason or another, we focused on a few particular features. And in hindsight, we probably should have done what we originally intended to do. So we're busy redoing the whole of the user interface, and I tell you, it looks great. I saw a copy of it today running on one of the developers' machines, and it really does look good. I think people are going to be quite pleased with what we've come up with, and we've come up with some amazing capabilities for it as well, which I'm going to show you. Whoops, that was not what I intended. So just to give you a taster of the capabilities, you get something like this. This is a log out of a web server. Okay, so you can see it's a log out of a Microsoft IIS server, and it's got lots of really useful information that you can use in conjunction with network traces. But unfortunately, it's not in a great format, and it's not very easily searchable, and you can't do clever filter terms with it or anything like that. So what we did was we managed to write a translator, and basically we've translated that data into Wireshark. So
wow.
So using this now, what you can do is you can simply step through a trace file, step through a log actually in Wireshark. Now this is just the first piece of this, because of course the next thing is, if we merge this, and we can do this right now, we can merge it with the network trace and actually have this enriching the network trace with weblog data. And the benefit of that is that if you've got network trace data that has encrypted streams in it, like encrypted web requests, then by merging in the log files and doing some time adjustments, we can enrich that data with the actual metadata from the log file. So this is something we were determined to do. We've got a couple of other really neat ideas as well that are very similar to this.
This is awesome. If you're a security analyst and you're trying to find when a breach occurred, or when a data leak occured, or
absolutely,
anything like that.
I can filter on any of these terms. So if I say apply as a filter, and I can just filter on that IP address, and I'm filtering. What I'm doing is I'm filtering a weblog. I can filter on all examples of this particular URL.
Right.
And again, it just picks out all those URL examples.
When will this be available?
This will be available. It's going to be actually incorporated into the next release of Workbench, because we're installing a number of translators into the back end of Workbench, and it will be seamless. So what you'll be able to do is you'll be able to go to a log on the Workbench, and it will appear on the Workbench as an icon, and you'll be able to right-click and launch that log into Wireshark seamlessly, and it will just launch and open.
When do you think that'll be available for someone to use? The reason I'm asking is I have a need right now, but...
Okay. Well, we'll talk about your need offline. Okay. Because I can probably give you something that will do what you need.
Okay. That'd be awesome.
And in terms of the big wide world, it's going to be probably another 2 months, I would imagine. We have some big decisions coming up on Workbench. I can't go into them at the moment, but I will share them with everyone as soon as I've got the answers out of our board.
Yeah, but do you realize how powerful this could be for a security analyst?
Yeah.
Oh my God, this is.
Well, what we did was we thought we were thinking about viewers. So how do you view log data? How do you view Microsoft ETW data? What's everyone's favorite viewer? Well, everyone's favorite viewer is Wireshark. So why not just think of it as a viewer and then just translate data so that it can view it as though it was just another trace file?
Oh, I mean, you do realize how powerful this is going to be for analysts.
Yeah, I hope so. I truly hope so, because that's the whole point of this is doing this.
I was on a long call yesterday with someone trying to figure out how we took an Excel version of a log file and compared that to the trace files.
Oh yeah. Well, actually, the thing is that in the next version of Workbench, and it probably won't be in the first release, but you'll be able to drag and drop Excel onto a trace file, and it'll automatically do the translation and produce a CSV, and it'll open it in Excel. So we're focusing much more on data translation and the integration between two. Thank you very much. Thank you. Okay. I think I've taken up a lot of time here, so let's just finally touch on where do you get Transum? Well, you download it from the TribeLab website. Go to the website. It's free of charge. Get in there. We've got lots of support information in there, including a full user guide, and just get in there and make some use of it. I think you'll really like it.
Yeah, I think it's got some. You've developed it way beyond what I believe you thought it was going to be in the very beginning.
Yeah, quite possibly.
Yeah.
I need to now figure out how to stop my screen share.
At the bottom, stop sharing.
Yeah, but it doesn't. The stop sharing thing is gone, hasn't it? Because I closed it.
Well, that's Google. They want to make it hard on you.
That's not Google. That's Tim wanting you to.
There must be. Oh, here we go. Here we go. Cancel.
You're back.
I'm back. Okay. All right. Wow. 6 o'clock. Wow, that was really well timed. I'd like to tell you that I intended to do that, but that would not be true.
Timing is great. Timing is great. We should definitely close the show at around the 30-minute mark. Well, Tim, last remark.
Well, I mean, Paul, you're taking this way beyond what you told us originally, and originally Transum was just a very nice response time analyzer addition, and now, oh my gosh, the things you're adding to that workbench or bench. What's it called? Workbench?
Yeah, workbench. Yeah. No, that's right. I think the data translate. We've got some pretty clever ideas with the data translation piece. So,
well, that's always been the problem, right? I can capture data. Anybody can capture packets, right? It's how do you understand them? How do you translate them?
Absolutely. Well, do you know that Windows out of the box has 657 diagnostic data providers that are providing trace data?
Yep. And
who is using 5 of those? I don't know anybody who's using any of that data, and it's really rich. There's RPC data in there. You can watch the internal components of Windows talking to each other over RPC. And
oh my God!
So what we're going to do is we're going to take that RPC data and translate it so you can look at it with Wireshark. Then you'll just be able to use it just like any other diagnostic data or any like trace data.
That's awesome. You've done a great job on that, and from my perspective, thank you so much, because just even that log capability, log perspective to packet flow is very powerful. And when I had talked to Gerald recently, and I want to make a quick announcement if I can, Denny, the ISSA has will award Gerald November 4th, I think it is, an award for his work and efforts with Wireshark.
That's great. He deserves it.
At the National Convention in Dallas, Texas.
Wow. Cool. Okay. Very nice. Very nice. Good job, Tim. I know you don't want to take credit for that, but I'm saying anyway.
But it's well deserved. I've been amazed. I've been amazed that no one has ever recognized Gerald for that. And when I tried to get a local congressperson to do it, I was told it was not that relevant to her.
Oh, wow.
So, thank you, Ms. Boxer.
All right. Anything else, Paul?
No, thank you very much for having me on, and I promise I'll be back as soon as I've got some concrete news on Workbench, because I think you're going to love that. So we'll do something.
I look forward to an article.
You might want to, I was just thinking out loud, Tim, we have a lot of people on a mailing list who are past authors and contributors to Love My Tool. I know how engineers, Paul included, would prefer to talk about things when it's nice, when it's done. But sometimes, from a marketing standpoint, sometimes it's good to get people on in early, so it can give you some feedback. I was wondering if it makes sense to arrange a kind of roundtable with some of our friends, and kind of, I'm talking out loud. I mean, just kind of bring up this amazing capability and see what people think.
We could easily do that. I mean, it'd be good to have an open, as Paul gets closer and has a little bit more firm grab on what he's doing, and wants that feedback. I say because we can get Jasper, and we can get Paul, we can get Tony, we can bail Chris out of jail, we can maybe even bring Mike Panaki, and bring the group that we all, get Betty, maybe. Poor thing, she works so hard though, she travels all the time. But maybe get Betty, Laura.
Well, we should probably get Paul to talk to Paul privately on this. But I was just thinking out loud that I just have a feeling that this thing that Paul had just kind of slipped under the radar. They said, "Oh, by the way, we're doing this. This is going to change everything."
It is. I think it's. I guess the fear we have at Advanced 7 and in the TribeLab project is that nobody cares. You know, that we're maybe we're the only people, or you know, that the people you've mentioned are the only people who really want to access this data. I hope that's not true, because they're missing out on so much. And
yeah, but you're beginning to appeal to a whole different level when you move from the traditional packet analyst group to people that are doing security, whether it's proactive, post-event, pre-event, just even knowledge base. And I know for a fact, bless you, Denny. No problem, bless you. In just a month or so, there's going to be a new class in the federal government about networks and being able to use, you know, send agents in to be able to do things on networks. And something like this being I mean, just a simple, you call it simple, I didn't, but, you know, using your words is the simple ability to take, you know, a log file and compare it to the packet flow, and the quick filtering is just, you know, and I definitely will be working hard to see if I can get you to present some of that stuff at one of the conventions, one of the security conventions over here.
Yeah, well, in entrepreneurship, we call this a bluebird.
Yeah.
This is you know, I got this great business plan. I got these people working on this idea. I have these customers, and you know, this is how we're going to change the world. You just execute it, all of a sudden, boom, and you say, "Wait, let me drop this." Yeah. So I really well. Anyway, let's close the show, and then Paul, you know, we kind of booked for the Wednesday time slot, and then I have some traveling, but we should really put some what we call put some wood behind this arrow. I mean, this is really something amazing, and you know, if it means that we should do a show for you every other week on Monday to kind of get some visibility to this, I think we should do it. This is exciting. This is really exciting.
Okay.
Yeah. All right. Okay.
Paul.
Thank you, Paul. Thank you, Paul.
Okay.
Thank you, Tim.
Thank you.
And thanks, everyone. And we'll be back next week, probably on Tuesday, with hopefully one of our new sponsors, and we'll talk about security. Thanks, everyone. Bye-bye.
Bye-bye.